You may have heard of the stars, planets and galaxies that make up our universe. But did you know that there's something else out there that scientists call dark matter? Dark matter is a mysterious substance that makes up about 27% of the universe. It is called dark because it does not emit, absorb, or reflect any electromagnetic radiation, making it invisible to telescopes. However, scientists have inferred the existence of dark matter through its gravitational effects on visible matter. The search for dark matter has been one of the most important quests in modern physics and astronomy. Scientists have been trying to understand its properties and behavior for decades, but so far, it has eluded detection. Despite this, there is a wealth of evidence that suggests its existence. The first indication of the existence of dark matter came from the rotation curves of galaxies. The rotation curve is a graph that shows the speed at which stars and other visible matter are moving around the center of a galaxy. Scientists observed that the outermost stars in a galaxy were moving at the same speed as the innermost stars, a phenomenon that could not be explained by the visible matter alone. To account for this, scientists proposed the existence of a large amount of invisible matter, which we now call dark matter. This evidence was later reinforced by the study of galaxy clusters, the largest structures in the universe held together by gravity. Scientists found that the gravitational pull of the visible matter in galaxy clusters was not enough to keep them together. Once again, this could only be explained by the presence of a large amount of invisible matter, which we now know as dark matter. The study of cosmic microwave background radiation also provided evidence for the existence of dark matter. The cosmic microwave background radiation is the afterglow of the Big Bang, and it provides a snapshot of the early universe. Scientists observed that the distribution of matter in the early universe was not homogeneous, but instead, it was clumped together in certain regions. This clumping could only be explained by the presence of invisible matter, which we now know as dark matter. So, what is dark matter made of? This is one of the most important questions in physics and astronomy, and it is still a mystery. Scientists have proposed several candidates for the nature of dark matter, but so far, none of them have been confirmed. One of the most popular candidates is the weakly interacting massive particle, WIMP. WIMPs are hypothetical particles that would not interact with light or other forms of electromagnetic radiation, making them invisible to telescopes. They would, however, interact with other forms of matter through the weak nuclear force, which is one of the four fundamental forces of nature. Scientists have been searching for WIMPs for decades, but so far, they have not been found. Another candidate for the nature of dark matter is the axion. Axions are hypothetical particles that were first proposed in the 1970s to solve a problem in the theory of strong nuclear interactions. Like WIMPs, axions would not interact with light or other forms of electromagnetic radiation, making them invisible to telescopes. Scientists have been searching for axions for decades, but so far, they have not been found. Other candidates for the nature of dark matter include sterile neutrinos, which are hypothetical particles that do not interact with light or other forms of electromagnetic radiation, and primordial black holes, which are small black holes that could have formed in the early universe. The study of dark matter is an active field of research, and new discoveries could help us understand more about the universe and how it works. Scientists are using large telescopes, particle accelerators, and underground detectors to search for dark matter. One of the most promising techniques for detecting dark matter is through the use of underground detectors. These detectors are designed to detect the very rare interactions between dark matter particles and normal matter. One of the most sensitive detectors currently in operation is the Large Hadron Collider, LHC, at CERN in Switzerland. The LHC is the largest and most powerful particle accelerator in the world, and it is designed to search for new particles and forces, including dark matter. Another promising technique for detecting dark matter is through the use of space-based telescopes. These telescopes are designed to search for the faint signals emitted by dark matter particles. One of the most ambitious projects in this field is the Euclid mission, which is set to launch in 2023. Euclid is a space telescope that will survey the sky to study the properties of dark matter and dark energy. In summary, dark matter is a mysterious substance that makes up about 27% of the universe. It is called dark because it does not emit, absorb, or reflect any electromagnetic radiation, making it invisible to telescopes. Scientists have inferred the existence of dark matter through its gravitational effects on visible matter, and several candidates have been proposed for its nature, including weakly interacting massive particles, WIMPs, and axions. The study of dark matter is an active field of research, and new discoveries could help us understand more about the universe and how it works.